This is pre-calc, day 2 of 4.7. We're going to talk about the law of cosines today. Yesterday, we talked about the law of sines, and it ended up giving us a potential option for an ambiguous case. Well, today, we have to use the law of cosines on some of these triangles that you're not allowed to use the law of sines, and that would be of a side-side-side situation and a side-angle-side situation.
Same note outline?
Yes. And so, what we have here is a law of cosines. There are 3 formulas, but they really essentially are the same thing. I would not say memorize all 3. It's the same standard triangle. It just makes the connection between an angle and the side opposite. So if you look at the first formula, it's a squared, so side a squared, is equal to the other 2, b and c squared, add them, and then subtract 2 times bc times the cosine of a. So all of them have the same pattern to these, and so I would highly suggest that you say, hey, remember the pattern. You can use it for any triangle where they change your variables. It's always using the angle and its pair across from it, and then the middle is made up of the other 2 sides. This is going to help us not have to worry about extra solutions because your answers should be laid out for you. Okay, so here we go. The first problem is that a group of friends are on a camping trip, decide to go on a hike. According to the map that is shown, what is the angle that is formed by the 2 trails that lead to the camp? Now, it's important that you guys realize what does it mean to be a trail that leads to the camp. A trail goes both ways. I can go away from the camp and I can go to the camp. So therefore, I'm going to take a walk. I can go to checkpoint 1, I can go to checkpoint 2, and then back to the camp. I'm assuming that would be the path that they took. This forms a triangle if we're taking the direct approach from one trail to the other checkpoint and so on. Now, if we're talking about what is the angle formed by the 2 trails that lead to the camp, I think everybody should be able to look at this and say checkpoint 1 to checkpoint 2 is not a trail that would lead me to the camp. So I'm not trying to use this side. That's not one of my sides I need to find the angle between. So it's from the camp to checkpoint 1 and camp to checkpoint 2. I am trying to find the angle between those 2. Now, if you notice, there's no A, B, C, or X, Y, Z's of here. There's not a triangle that's named that way. We can arbitrarily call it those. Naturally, camp starts with a C, so why don't I call that C? So if that's C, then this is little c. The other 2, it really honestly does not matter. Let's call 2A and 1B. Notice I don't even care what the other 2 angles are. I'm not asking for that. I'm asking just for angle C. And so, if this is the case, I'm going to use the third pattern over here. Okay? Which is C squared equals A squared plus B squared. So C squared, which is 1.5 squared, equals A squared,
Which is
2 squared, plus 1 squared, minus 2 times 2 times 1 times cosine big C. We don't know it. Once I fill this in, guys, it becomes more of like an algebra 2, say, problem. And you just have to solve for C. But to solve for C, I need to solve for the function which C is in, which is cosine. What's 1.5 squared? 2.25 equals 4 plus minus 4 cosine C. So it's pretty easy, right? And then 4 plus 1 is? So can I just subtract 5 from both sides? All of that's gone. What's 2.25 minus 5? Negative 2.75 equals a negative 4 cosine C. Got to get cosine by itself, bless you, and so we divide both sides by negative 4. Cosine C is equal to 6.875. So wait a minute. Is that an acceptable ratio for a cosine? Yes, because it's between negative 1 and 1. So I'm going to go now and take the inverse cosine. Inverse cosine exists in quadrants 1 and 2 because it's positive in 1. Now, here's something interesting. That means C is going to be here. And if I take the inverse cosine, it's what? Ooh, make sure you're in degrees because we're going to talk about degrees in this problem. What angle did we get?
46.
47, okay. So, ladies and gentlemen, it's getting a little noisy here. Now, wait a minute, guys. 47, that's great. And if it was negative, it would be over in the second quadrant, which is not. But this is an equation. I'm solving for C. That means cosine has another positive answer somewhere else. Which quadrant is cosine also positive?
4.
It's in 4. So that means I can use 47 as a reference too, right? What would it take to go all the way around? Something like 313. Wait a minute. I have a triangle. Can 313 actually exist there?
No.
No. So I don't even have to worry about it. Hence, how many solutions?
1.
1. C is 47 degrees.
Wait, why can't 313? Oh, because it's not a...
Because it's more than 180. The next problem, guys, is dealing with the side angle side. Because when we make this triangle, because it's not given for us, you're going to find out that you have an angle between two sides that are adjacent. And so therefore, we're going to have to use a law of cosines again. If I'm not given a triangle, I'm going to make it. H, J, K, which is H, J, and K again. 34 goes out degrees at H. J is 7 and K is 10. You guys agree with this? Now, one reason that I know that I have to use law of cosines instead of law of sines only works if you're given a side angle pair. Do we have a side angle pair? What side and angle do we got? None. We're not told any of them as a complete pair. Every single one of them is missing one piece, so I can't use it. So if I go to law of cosines, I will have everything I need to solve for H. Because if you look at it, the law of cosine says that its side squared will equal the other two sides squared, subtracting 2 times those sides, and a cosine of the angle. So that's really nice. It doesn't matter which side you put first. So H squared is 10 squared plus 7 squared minus 2 times 10 and 7 cosine of the angle, which is 34. Hey, look at that. All of the stuff on the right-hand side is stuff I can do on a calculator or in my head. And then all I have to do at the end is take the, not inverse, but the, get rid of square, so I take the square root. So I'm going to simplify some of this at least. That's 149 minus 140 cosine 34. 2 times 10 is 20. 20 times 7 is 140. 100 plus 49 is 149. And now I can take the calculator out. What's 149 minus 140 cosine 34?
9 cosine 34.
No, you can't say 9 cosine 34.
No, I know.
Because that doesn't have a cosine 34 attached to that 149. So it's going to be something like 30,
I got 33.
That's right.
32.9.
But can't you round it?
We don't round until the very end. We didn't solve for h yet.
Oh.
Square root, h equals 5 point. What's the square root of 32.9? Should be 5.7.
Yep.
So we found h. Now, you have options. You now have all three sides. You can do what you did in the last problem using law of cosines to find any of the remaining angles. If you use a law of cosines, you will always find the one answer that works and you're happy. Law of sines. When I did this first during second hour, I got one answer. I just did it last hour with the other angle and I ended up finding that we get two answers, but I don't think I did something right. So, let's try this again. Okay, now, I personally don't like the fact of using the law of cosines. It's a little bit more involved, especially when I have to take the inverse cosine. I personally like the law of sines, even though there's a possibility of some weird stuff going on there with the ambiguous case. But the biggest thing that we have to remember is that the largest angle gets the largest side, and so forth. And so, by getting 5.7, I'm hoping everybody realizes that that just completed a pair. So I can do sine of 34 over 5.7, right? So in that case, isn't that the same thing as sine of some angle j over 7? And can I solve for j? Multiply both sides by 7. And what does 7 sine of 34 divided by 5.7? There should be a ratio. And hopefully this ratio is between negative 1 and 1. What do we get? What's that? You got 43, but what's the ratio first? 0.68. And J means, J would be 40. Garrett, what'd you say? 43 degrees.
Wait, how'd you get that? 43 degrees. Oh.
Now, wait a minute, guys. So you're saying that if I go up here and put a 43, it'd be very easy to solve for k. Would you guys agree?
Yes.
Because all three should add up to
Wow.
180. So 43 plus 34 is 77. So that leaves me with a 103. We've now completed the triangle. But do you guys remember we're solving for j using an equation? I need to take a look at all values of sine. That could possibly give me a positive 0.68, right? This angle of 43 is one of them. It is also positive in the second quadrant with a reference angle of 43, which means I can get there the long way here. What angle? 100 and 137.
Yeah,
Dave says 63.
Now, here's a question. Think about this. That means I should be able to take out 43 and swap it with a 137. I'm going to change colors so we can put it right in there. Would 137 be a viable option for angle-wise? Because as 137 plus 34, is that still less than 180?
yes.
You guys agree with this? Which would leave me with how much left over? 9. So you'd have to have a 9 over here. But can you actually construct a triangle with those degrees and those sides?
No.
10's the biggest number, needs to be opposite the largest angle, and with the purple, it doesn't exist. So therefore, you cannot use those, and the black 43 for J and 103 for K is the only triangle that exists. Now, I'm going to fair warn you. Some reason I did the same thing for K, and I got 2 acceptable answers. So I am actually looking into that at this point to make sure I'm doing my math correctly. And I'll be getting back to you guys about why it should or should not work. But any questions on this? It makes sense, right? Your biggest side gets the biggest angle, so forth. And moving on from here. What if I said, I want to know the area of a triangle? Because that's nice to know sometimes. We got Heron's formula. And this is for a triangle where you know all 3 sides. It's a fairly simple formula. You just take the square root of s times s minus a times s minus b and s minus c. And you're like, what's s? Well, s happens to be half of all the sides added together. So you just have to remember, add up all the sides, divide by 2, and then multiply that number times the differences of all the sides and take the square root. So it's a fairly simple thing once you understand what the formula is to actually make it work. So our problem there is in the middle of the page. It's 24, 53, and 39. The cool thing about it is if I'm looking for the area and I got all the sides, I don't need to make a triangle to show any work that way. What I do need to do is say I need to find s. And s is 1/2 24 plus 53 plus 39, which is half of, taking a calculator out or in your head, 5. So 70. 70 plus 30 is 100. 9 plus 4 plus 3 is 16. So 116. And half of 116 is 58. Cool? Now just use the formula. Take 58. Take 58 minus 24. 58 minus 53. 58 minus 39. What's 58 minus 24? $58 minus 24 is 30. $58 minus 53. And 58 minus 39. Take a calculator, multiply them all together, take the square root. You end up with 400, what?
32.8.
32.8. All the dimensions in this problem are in centimeters. So if I'm talking about area, it's centimeters squared. Done. Easy enough if you're given all the sides. Add them all together, divide by 2, find the difference between all of them, multiply them together, take the square root. But what happens if I'm not given all the sides? This is the last thing we'll have to do. The last thing is just the area of a formula given a side, an angle, and then the side. Remember, it's all in a row. There are 3 formulas there again, but you don't have to memorize all of them. You notice that there's a link between all of them. You're going to take the sine of the angle, but then you just take that and multiply it to half of the sides that were given, that are around that angle. So if you have angle A and the 2 sides around it, it's half of BC times sine of A. Or it's half of AC times sine B. Is the angle of the missing sides. Or the missing side, not sides. So it's pretty simple when you take a look at that and you take a look at your problem below. And it says, side, I got a 25 yards, I got a 25 degree angle and a 20 yard side. Side angle side. That means area is equal to 1/2 something, something, sine, something. What's the somethings? What's the first one? Does it have to be 25? No. It could be 20, but then the next one would have to be
25.
Right. So we're going to switch those. Those can be in any order, but the angle itself has to be 25. Put this on a calculator. You got the area is equal to 100. 105.6 yards squared. So that's it, guys. So your homework on 4.7 day 2, page 298, 32 through 34, 40 through 42, and 45 through 47. Each one of those groups deals with the 3 different concepts that we dealt with today and the 3 different types of formulas. So have a great day.
Thank you.